Hello and welcome back to another video in the Unreal Engine 5 tutorial series. In today's video we are going to be going over materials. And this video is actually scripted. I'm going to be going through the Unreal Engine documentation to make this video better. Let's see. So what are materials? Materials in Unreal Engine define the surface properties of the objects in your scene. In the broadest sense, you can think of a material as the paint that is applied to a mesh to control its visual appearance. In more technical terms, the materials tell the renderer exactly how a surface should interact with the light in your scene. Materials define every aspect of the surface, including color, reflectivity, bumpiness, transparency, and so on. These calculations are done using data that is input to the material from a variety of images, textures, and node-based material expressions, as well as from various property settings inherent to the material itself. First, we'll be going over essential material concepts. This section provides a high-level overview of the material creation process in Unreal Engine. Creating a new material. Materials in Unreal Engine are an asset class just like static meshes, textures, or blueprints. You can create a material from the content browser. First step, right-click, and then select Material. A material is created in the content browser. We can give it a name. I'm going to do m_example. Double-click the material asset to begin editing it in the Material Editor window. The region with the checkerboard pattern in the background is the material graph. The material graph in a new material is empty except for the main material node, which contains all inputs that dictate the appearance and behavior of the material. Material properties. When the main material node is selected, the global material properties and settings display in the Details panel. You can also display the material properties by clicking any empty space in the material graph. 3 of these settings are particularly important at the beginning of the material creation process as they form the underlying foundation of a material and dictate how it can be used. They are Material Domain, Blend Mode, and Shading Model. Material Domain defines what the material will be used for in your project. For example, surface, user interface, and post-processing materials are different material domains. So you could see that as if it's an actual 3D space object, if it's being used in a 2D UI, or the other examples. Blend mode defines how the material blends with the pixels behind it. For example, opaque shader completely occludes objects behind them, whereas translucent and additive shaders blend the material with the background in some way. So, say you want glass, it would be translucent. Or if you want some kind of like highlighter paint marker, you could use like adaptive, something like that. Shading model defines how the material interacts with light. Very often, your materials will use the default lit shading model. However, Unreal Engine includes specific shading models for things like hair, cloth, and skin, which provide context-specific inputs to make it easier to create those types of surfaces. For example, with, say, hair, it might allow for a mix between opaque and translucent areas. These properties determine exactly which inputs are enabled on the main material node. In the example above, opacity is grayed out because the opaque blend mode does not support transparency. If you select the translucent blend mode, you then see that opacity input is enabled, and several inputs that were previously enabled are now grayed out. Go back to opaque. When you create a new material, it's recommended that you configure these 3 properties first. Material expression nodes. If material properties are the foundation, material expressions are the building block of a material. Each material expression performs a specific action in the material graph. Technically, a material expression is simply a visual representation of a snippet of HLSL code. When you combine material expressions, you are writing an HLSL shader without ever having to mess with the code itself. Data is passed between material expressions by dragging a connection cable from the output pin of one node to the input of another. Here's an example. Add and texture sample. You can drag from one to the other. It also works in reverse. You right click to bring up this little search box. Simple surfaces might only require a few material expressions to define the material. For example, let's see, so you can open up the content drawer. If you go into your starter content textures, you will see a variety of textures here. Let's say we want to make this clay brick. We can shift click these. Yes. Okay. We can bring these in, and you'll get these texture samples. They're basically a sample of the texture that you can modify without modifying the base texture. Not too positive what this is, so I'm just going to exclude it for the moment being. You have the texture, and then you have this is called a normal map. You see this here? This is a normal map. It is a way of adding detail without adding polygons. Okay, so you just saw that I dragged these out, and I imported them into the scene. Simple surfaces might only require a few material expressions to define the material. As below, where you can see these two, this can go into base color, this can go into normal. As you can see here, they define the material. And there aren't any other nodes in this graph, but you can add them. This could be a finished material, or you could continue refining the surface using math and logic in the material graph. Understanding how to combine material expressions to achieve specific results in your material is the basis of material creation in Unreal. The main material node. Data flows from the left to the right in the material graph, and the main material node is the endpoint of every material network. The main material node contains the final input pins that determine what information is compiled within the material. Material expressions in your graph do not affect the material unless they are a part of the chain that connects to the main material node. For an example, say I remove this base color and then I do multiply by b, whatever. And let's say I just give that a value of 2. And then I take that and I move it into base color. That works. But if I disconnect it, well, it doesn't, this goes nowhere. It only affects when it's connected all the way through. Compile and apply. Changes to a material cannot be seen in the level editor until the material is compiled. To compile a material, click the Apply or Save button at the top of the toolbar in the editor. After compilation, you can drag a material from your content browser directly onto any actor in your level. Compilation can take a few seconds or up to several minutes for complex material. This can potentially bottleneck your efforts when developing and testing materials, but there are several ways to minimize compilation delays. The procedures outlined above cover the basic material workflow in Unreal Engine. Each one of these steps will now be discussed in more detail. Material Editor User Interface. The Material Editor UI consists of a menu bar, a toolbar, and the 5 main regions I will now show. 1, 2, 3, 4, 5, 6. Viewport panel. The viewport panel displays the material that you are currently editing. You can navigate in the viewport panel by using the same, or by clicking with your left mouse button and rotating around. You can also zoom in and out using the scroll wheel. Details panel. This details panel is very similar to the details panel in the main editor, but it is specific to whatever is in that material component. The material graph panel is this right here. It is the graph of your material, and it shows everything that ends up getting compiled. Only things that are connected to this input will ever be compiled. The materials you create are very rarely single-use assets. Authoring an entirely new material for every actor in your project is inefficient, particularly because similar assets tend to require very similar materials. Material instances and material functions make it easier to customize and reuse materials so that you can iterate faster and avoid doing the same work twice. Material instances and parameterization. Material instances provide a way to quickly create multiple variations or instances from a single parent material. Instances are used when a group of related assets require the same basic material but with different superficial characteristics. An example might be a piece of furniture that has several color variations. Material instancing lets you create a single parent material for the furniture set. You would then create a material instance for each color. There are several advantages gained from using instances. You can customize material instances without recompiling the parent material. This means that changes you make to instances are visible immediately in all viewports. You can expose parameters to artists in the material instance editor. This means they can quickly and intuitively create variations of a material without ever editing the more complicated node graph. This is more important whenever you are working in a group, say using Unreal Engine in your job. Whereas a typical material cannot be changed without recompiling, something that must happen prior to gameplay, a parameterized material can be edited in a material instance without such recompilation. This has numerous workflow advantages and can improve the material performance. Okay, to show this off for material instancing, I am going to promote the roughness of this variable to a parameter called roughness. And I'm going to set its default value to 1, max roughness. Now, if I recompile this material, and I look here, I can right-click and create material instance. Now, if I double-click that material instance, I should be able to see its roughness, which I can then left-click on roughness, this little checkbox here, to be able to modify its roughness without having to modify the base material. So this really only does take, it only really works at values between 1 and 0. So let's try to fix that. In order to do that, I can do a slider min of 0 and a slider max of 1. Now, whenever I compile and save, I now have a slider that allows me to go between 0 and 1 to see how that affects this material. And if I apply this to this brick, to this object here, I can now pull that apart from that, and I can modify how rough or shiny it is just by pulling on this slider, and it affects it in real time. This can be very powerful whenever you have bigger materials, because instead of having to compile every time that you change that value, you just compile it once, and it works. I could also upgrade these material, I could also convert these to parameters. I could call it texture 1, and let's see, convert to parameter, texture normal, normal. Now if I save this, you can now see that I can override the texture to be any other texture. Let's say I want that to be, oh wait, no, that's a normal map, dumbass. I could set that to be that, and I could set that normal map to be a different normal map. We probably want the normal maps to match, so I'm going to do old brick clay n and uh, old brick clay, and clay beveled. I don't know. I'm just trying to. Oh wait, that's the same one. Let's see. So I'm gonna do that normal and that other map. Now, if I look back here, it's a red brick, and I didn't have to do any recompilation for that. I just have to save it. The relationship between materials and material instances is a parent-child relationship. A material instance inherits all of its attributes from the parent or master material. For this example, this is the material graph for that brick structure. Any material instances created from M example inherit all the attributes in the graph shown above. Because of how they inherit attributes from their parent, newly created material instances appear identical to the parent material when applied to objects in the level. As you can see right here, if I create another material instance, and I put this here, and then I put this one here, they look identical, bar the stretchness of this because I have not compensated for stretch yet. The key workflow benefit of material instances is that you can very rapidly customize them in the material instance editor without ever editing the node graph or recompiling the material. As you can see above, whenever I double click on this, I can, edit like I've shown before. It is important to know that you cannot edit every single characteristic of a material instance by default. To make material attributes editable within the instance, you must designate them as parameters. Remember how I had to right-click this and do convert to parameter? This is called parameterizing your material. A parameter is created like any other data node in the material editor and contains the same information as its non-parameterized counterpart. For example, a constant expression consists of a single floating point value and is frequently used to control material inputs like roughness and metallic. As you can see here, it's controlling the roughness. The parameterized version of this node is called a scalar parameter. Notice that the scalar parameter also becomes a named value which serves as a way to show what it controls. It is important that you give every parameter a unique descriptive name in the details panel. Select the node in the materials graph to edit it in the details panel. As you can see here, you can edit its name, you can edit its default value, and its sliders. To show this point further, if I just take a constant of say 0.5 for the specular, and then I save and apply, this will not show up in the material instance editor, even though it will affect every single material based off of it. Specular isn't really that visible here, but so if you want it to be editable, you can right click and you can select convert to parameter, and then I can just specular. Specular, whatever. Now that it's converted to a parameter, if I save and I look over here, I now see a specular that I can modify. So let's say I want to take this down to a roughness of there, and I want to take this to a specular of there. Now it's done. And I can just save that. You don't really have to, but you can see that now this looks different from this because I modified the value. I can also do the same thing here. I believe its max is also 1, so parameters can be used anywhere in your material graph to derive a wide range of material effects. Scalar parameters. A scalar parameter is a parameter that contains a single floating point value. Scalar parameters can derive any effect based off of a single value, as seen in the roughness example and in the specular example. Scalar parameters are also used to control the multiplication factor of an attribute. Vector parameters is a parameter that contains a 4-channel value or 4 floating point values. It can be seen, let's see, if I vector parameter, let me just name this, I can rename it here to new new vector. Base color. That'll work. Okay, now we can basically make this kind of brick. We're getting that brick shape from the normal map. If I go, oh yeah, I haven't compiled anything, but yeah, that's where that's coming from. So it still kind of looks like bricks here, and now we can make it like any color, because that is a parameter. So if I save that and I go here, I can now select basically any color I want. Make any color brick in the material editor, or sorry, in the instance editor. Texture parameters. The most commonly used one will be the most commonly used texture parameter is the parameter sample 2D, which allows you to change the texture within a material instance. There are other types, but I'm not going to be going over them right now because we don't need them. Static parameters are applied at compile time so they can be edited in the material instance editor, but not from a script at runtime. They can be used to mask out branches of a material. For example, if I right-click here and do static switch, if I take this static switch and I place this here, if it's true, it's that. If it's false, it's that. I'm going to give it a default value of false. I can name this, okay. Oh, wait, switch around. Static switch parameter. There we go. It's a static switch parameter. Okay. I'm going to name this texture for color. Texture color. Let's see, to texture false color, or no, yeah, that way. You saw what I did. Save. Now if I go back here, I can say it's a color, and then I can set its color variable. Or I can say it's a texture, in which case it's a texture. But that can only be changed here. It cannot be changed at runtime, so I can't use a script to change that. I can with most other types. Those are really the only important ones that are worth going over. A material function allows you to package parts of a material graph into a reusable asset so that you can share to a common library and easily insert into other materials. Their purpose is to streamline material creation by giving you instant access to commonly used networks of material nodes. For example, if we look at blend overlay, this is a material function provided by Unreal Engine. The Unreal Editor includes several dozen pre-made material functions. You can edit any material function to alter its behavior or create your own function directly within the editor, though I will not be going over that at this time, as it is a bit more of an advanced feature to create your own functions. That concludes our video for today on the essentials of material concepts in Unreal. I have been Daniel. If you need any further help or research, I will be including the Unreal Engine documentation in the description below. If you want any help from me, feel free to contact me on my Discord server, link in the description below. If you feel like supporting the work that I'm doing, I will be linking my Patreon in the description below. Any further questions or comments, please leave them in the comment section. Don't forget to give this video a like and to subscribe for more weekly information on Unreal Engine. In the next episode, we will be covering the physically based materials in Unreal Engine. Thanks for your time. Thanks for watching this, and have a good day. Goodbye.